Alright guys, welcome back to this channel, and in this particular video I'm going to be talking about big M. So in the last class that we had, we talked about Simplex Method, and I'm going to be dropping the link to that video into the description section so that you can go through it and be able to cope with whatever we're about to talk about in this particular video. So now we have a question on maximum. Somebody requested for me a maximum question in the last Simplex method that I did, so I decided to do a maximum question but using another method basically. So now this is the question we're going to be solving, and how do we know that we're going to be using big M to solve this particular question? So remember when we were talking about simplex in the other video, just like a recap, we mentioned all of these steps, and there was an emphasis on step 4 that to consider Simplex method, the inequality of the constraint should be less or equal to. But in a case where we have a greater equals to in any of the constraints, then we can consider using two-phase or big M method. So in this particular video, we are going to consider using big M method. All right, because we have a greater sign in one of the constraints. What do I mean? I mean this here is a greater equal sign, and this here is a greater equal sign, so we are going to consider using big M in this particular question. All right, good. So big M, there are steps to follow just like we did in Simplex method. There are also steps to follow while we are trying to use big M method to solve our LPP. Step 1 is modify the constraint so that the right hand of the constraint is non-negative. This implies that we shall multiply the constraint by -1 if the right is negative, which in turn changes the inequality. Step 2, convert each inequality to standard form. If a constraint is a less or equal to constraint, then add a slack. If it is greater, subtract an excess slack, which is known as a surplus variable. And step 3 is add artificial variable to the constraint identified as greater or equal sign constraint at the end of step 2. Also add the sign restriction I sub 1 greater or equals to 0. All of this will be clear while we start solving this question. Then step 4 is let M denote a very big positive number. If the LP is a minimization, then you add MA. If it is a maximization problem, it's going to be minus MA. Now in this question that we are about to solve, it is a maximization problem, so when it gets to the point where we have to add MA, it's going to be negative MA, right? Okay, so and step 5 is, after we must have done that, we will go through the same step that we used in our Simplex method. So let's get right into it. So we have a question, maximum Z is equal to 6x1 plus 4x2, and we have the constraint all over here. Now remember that the step 1 says that if by any means any of our constraint is having a negative sign at the right hand side, we should multiply both sides by -1, right? So that we don't want to have a negative sign in our right hand side of the constraint. So like this particular part of the constraint has minus both in the right and in the left, so but we're most considering the right part having negative, so we want to change that. So what we are going to do is we are going to be multiplying -1 to the right hand side as well as the left hand side. Okay, and by doing this, you see that the sign will change. We have a positive sign, the negative will go, and we now have a less than, because we have multiplied -1 to both sides. So having done this step 1, we move to step 2. We convert the constraint to a standard form. Right, that means if there is a less than in our constraint, we add a slack variable, and if there is a greater than, we subtract a slack variable. Let me add step 3 to what I want to do immediately, such that if I'm adding, I only add slack variable, but if I'm subtracting, I subtract the slack variable but also add an artificial variable. This is what I'm trying to say. Look at our question now. I just have to put some spaces. So here in the first constraint, there is a less than, so I'm going to definitely add a slack variable. That's fine. In the second constraint, there is a less than, so I'm going to be adding slack variable. That's the second slack variable, S2. Now, but in the third constraint, there is a greater sign, right? Which is what step 2 and step 3 is talking about. If there is a greater sign, I'm going to subtract the slack variable, and add an artificial variable. Is that okay? And if you should look at our step 3 very well, it said that we should add our sign restriction, which is I'm going to be adding slack variable that I added and the artificial variable. They are all greater than 0. I think that's clear, right? Okay, so now if you should look at step 4, it's saying that all of these things we've added, we should add it to our objective functions. So I added 3 slack variables and 1 artificial variable. So here there are 3 slack variables, just like we did in Simplex, just make them zeros. Now, because this is a maximization problem, I'm going to be adding a minus MA. That's why I'm adding a minus MA here. So I think we have a full graph now. All right, so now this is our question. This is what we're going to be working with in our table to get our final answer that we wish to get. To remember that from Simplex method we have a table which we explain, so please don't forget to look into the description section to check out for the link for the Simplex method, so you can actually understand how we got here on the table. So much more if we are talking about the big M, right? In a question like this, we would consider a table. Now this is what Simplex looks like, but for big M, there's going to be an addition to the features of the table. If you notice that we are now adding A1, right? Because we have just one artificial variable that we added. If it was 2 artificial, to be A1, A2, and by the way, so but note that when you are trying to construct your table, all of your artificial variable must be present in your basic variable. Because I have just A1, so I put my A1, then the remaining can be filled up with slack variables. If I have 2 A1, then if I have A1 and A2, then I will have A1, A2, then I can now add my S1, right? But the point is, all of my artificial variables must be present before I consider adding a slack variable. Okay, so let's see what we can do with all of this. So we can now fill up our table with the information that we have in our question. So we fill up with 6, that's CJ, right? 6, 4, that is from our objective function now. 6, 4, 0, 0, 0, and minus M, right? Then we fill up slack variable 0, 0, and minus M. Then for the first constraint, we have we have S1 basically. So there is no S2 in the first constraint, so I'll just have to be 0. There's no S3, so 0. There's no A1 in the first constraint, that's also 0, right? The second constraint is 3. 2. There's no S1 in the second constraint, but we have S2, so that's going to be 1, 0, and 0. Then the third constraint, that's 1, 1, 0, 0, then a minus 1 because we're having an x3. Then A1 is just 1. Okay, so we can fill up our answers. This is our B. So we have 30, we have 24, and we have 3. Okay, so now that we fill up the whole cells of the table, so what we want to do next is to know that how I can construct my ZJ is I multiply my CB and my my variable. So 0 times 2 plus 0 times 3. I actually explained this in when we were doing Simplex method. So and minus M times 1, you add them together, that will be what you're going to add to your ZJ, and that's going to be minus M, right? You do the same thing from this one, 0 times 3, 0 times 2, minus M times 1, and that will be what you are going to write here. So it's going to go on like that. You're going to multiply that, and it's going to go on and on. Okay, so I have this on and on and on. It's the same method, right? And that will be all for that. Okay, so if you notice, there is a slight change in Simplex, and just for me to be able to do my computation easily, for Simplex I actually used CJ minus ZJ, but here I want to use ZJ minus CJ, and when we're concluding, you're going to see the interesting part of it. So we're just going to be doing ZJ minus CJ, and yeah, so this ZJ here minus the CJ. Okay, so that will give me minus M minus 6, and on and on and on. So now that we have our table, so what you want to do, like we've also explained, I will always make reference to the simplest method, so make sure you watch the video. So here I'm going to look for the highest negative, which is minus m minus 6. Okay, and with that I need to find my active role, right? And how do I do that? I'm going to be dividing my b's divided by all of the entry I have in my active column. So it will be that 30 minus divided by 2, that's 15. 24 divided by 3, that's going to be 8. 3 divided by 1, that's going to be 3. Okay, so I'm going to pick the least positive among all of these r. That will be me my active row, and my 1 is going to be my key element, right? My pivot element. So now with that I can now know what to do from here. So here for my active element, I have to do row reduction such that every element above or below it are supposed to be 0, right? So, and to do this I need to first of all divide all through by the value of that active element, meaning that if it was 3, I would have said divide all through by 3 so that that one can be 1, but in this case we are lucky enough for it to be 1, so we have no stress about that. So here I'm going to be doing minus 3 r2 plus minus 3 r2 plus, it should be plus minus 3 r1 plus r2 basically. So yeah, that's correction there, and r1 should be r1 minus 2 r3. So just correct that for r2. Okay, so and while doing that, 6 and x1 is going to replace, because we are talking about the active column, is going to replace minus m x1 because we have to rewrite the new table now. Do we get it now? So let's see. So that's been replaced, and let's see what we can do with the filling up. So I've replaced these two stuffs, and I want to fill in my values based on the parameters I have. So I've divided all through, and I still have my r3 to be the same. So let's see our r2. So we are basically doing so this is minus 3 r3 plus r2. Okay, so yeah, that's just it. So we can now have 0, then have minus 1, 0, 1, 3, minus 3, and 15, right? Then if I'm to fill row 1, I'm going to use r1 minus 2 r3, so which is going to give me 0, 1, 1, 0, 2, minus 2, and 24. I'll do the same thing to get my zj. Now I got my zj, that times this plus, then I'm going to have my 6, 6, 0, and like that to the end of that particular row. Then zj minus cj, I'm going to be subtracting them together. I'm going to be having 0, 2, 0, 0, minus 6, m minus 6. Okay, so I'm still going to pick minus 6, right? Because that's the negative sign I can find there. That's the least negative, right? So I'm going to do the same thing just to make sure that I have all positive, because I'm working with maximization, and I've already changed the order of zj minus cj, unlike the simplest that I use cj minus zj, right? So I'm still having minus 6 there. That will be my active column, right? And what do I do again? I have to divide my b by every element in the column so I can get my active row. So this is going to be 3 divided by minus 1, that's minus 3. 15 divided by 3, that's going to be 5. 24 divided by 2, that's going to be 12. I'm going to pick the least positive again, and that's going to be 5. That's the least positive. And 3 is going to be my key element, right? So we are going to do the same thing as well. So row 2, like I said the other time, we were lucky that our key element was 1, so we had to just, it was not really effective. But now our key element is 3, so we have to divide all through by 3. Okay, so we have to divide row 2 by 3. So divide root 2 by 3, that will be 0. That will be 0 minus 1 over 3, 0, 1 over 3, 1 minus 3, and 5. So I've divided all of the root 2 by 3. Right? So now that we have 1 as our key element, then we can proceed with every other operations that we want to do on this particular table. All right, so I don't really need the R for now, so let me just focus on this. So my row 1, which have to be 0 because above and below the key element they have to be 0. So my row 1 will be R1 minus 2R2, just normal row reduction, and my row 3 will be R2 plus R3, so I can get 0. So let's get that done. So clearing all of these stuffs, I would have to start with, that will be 0. I'm starting with row 1, that will be 0, 3 over 5. I'm doing row 1 minus 2, row 2 of what I just cleared. So, and I'll be having the input that we have here. Okay, and if I'm to do row 3 from the table I just cleared, then that I'm just adding 2 and row 2 and row 3 together. So that's going to be 1, 2 over 3, 0, 1 over 3, 0, minus 2, and 8. So Zj, the normal way we get Zj, 0 times 0 plus 0 times 0 plus 6 times 1. That's going to be 6, like that, on and on and on and on. Then Zj minus Cj will still give me 0, 0, 0, 2, 0. Okay, now I've been able to get all positives, right? All positive numbers, right? So, which means that since my Zj minus Cj are now all positive, and I'm dealing with maximization problem, I haven't exchanged this normal Cj and Zj, then I can say that we have reached an optimal solution. Now, because we've reached an optimal solution, we can now bring out our values, right? That x1 is going to be 8, so write that down. So we don't have x2 on the table, so definitely that's 0. Okay, so, and if we recall from our objective function that we are initially given from the question, we will see that if we fix in our x1 and x2 like this, it will be that my z will be 48, and that's it. Very easy. So the part of big M is just to know how to know your way around your addition of MA on your table, on your CJ table. And note that if you are doing maximum question, you are looking for the fact that the rule Zj minus Cj rule is going to be greater than 0. If it is minimum question, then you are going to be looking for a Zj minus Cj less than 0 for you to know if you reached an optimum solution. So thank you so much guys for watching and for sticking around to the end of the video. Don't forget to like, share, and subscribe to this channel. That's how we are encouraged. That's how we know that, okay, yes, people are actually following what we are putting out there. And also don't forget to check the Simplex Method. I've dropped the link in the description section. Let me know your feedback about this video. Drop your comments and share with friends and family and those you think that really need this video. And until then, I'm going to see you in the next lecture. Bye for now.